Good day, everybody. This is Richard Bernhardt. I'm with Streakwave Wireless. I'm very pleased to bring you another Streakwave Webinars presentation. Today we're going to be speaking with Mimosa, a vibrant company providing backhaul and a lot of other solutions. You're going to learn about products. You're going to learn about solutions. We're going to go over a whole bunch of stuff, so get ready for an action-packed webinar. Let me tell you a little bit about who we are first, and then we'll get into the presentation. Streakwave is a value-added distributor, and we provide broadband equipment and backhaul and related products for the fixed wireless broadband industry. So we have a very wide range of manufacturers and an extremely wide range of products for all of your fixed wireless needs. Streakwave specializes in providing applications and solutions for all of its clients. So if there are questions that you have, you can always contact Streakwave. The products that you see in today's webinar are available through Streakwave. You can access Streakwave through our website at www.streakwave.com, or you can give us a call at 888-604-5234. These numbers will appear periodically through the webinar, and at the end of the webinar, we'll make them available to you whenever you need them. Today's topic is a great one. It's talking about new directions in fixed wireless. Mimosa is a vibrant company, and we've got the Chief Product Officer and co-founder to present today, Mr. Jaime Fink. He's going to walk us through the products, the applications, the solutions, and then when we get to the end of the PowerPoint presentation and the discussion, we're going to have a discussion with you. We're going to do it digitally, so please, if you have questions that you'd like answered throughout the webinar, type them into the digital section and we'll do our best to answer them. If we can't answer them online, we'll get back with you offline via email or via phone call, whichever you prefer. So it's my great pleasure this morning to introduce Jaime Fink. He is, in fact, the Chief Product Officer and co-founder of Mimosa. Welcome, Jaime, and why don't we begin?
Thank you, Richard. I really appreciate you having us here, and I appreciate everybody coming from so many different countries and time zones. I know it's in the middle of the night for many of you, so we'll hopefully keep this very interesting content for you today and give you, obviously, a little bit of what's been happening with Mimosa with products that we've already started shipping. And also what's coming in the future and what you can expect, because I think what you'll see with Mimosa is we represent a completely new wave of evolution in the wireless technology, and that really bears with some of the future products and where we're going as an industry as a whole. First, a little bit about my background that's, I think, pretty relevant to how we got here with Mimosa. I'm actually a reformed fiber-to-the-home DSL guy. So I actually spent most of my career in the last 15 years building out ADSL, building out the VDSL fiber to the node, as well as fiber to the home networks. Much of my career was spent working with AT&T on delivering the AT&T Uverse service. So I became really versed in the costs of delivering services and also the kind of meteoric rise of Wi-Fi for home networking technology. But I think what really drove Mimosa to get where we are today was we saw how quickly the industry was shifting with the costs of fiber technology to be delivered, and that there was a very, very different dynamic happening with wireless that was clearly showing that wireless could eclipse the speeds and performance of typical wireline networks at a fraction of the cost. And that's where really our story begins. Mimosa, as we started the business 3 years ago now, back then, actually, there was about 2% of the industry of fixed broadband, fixed technology was wireless. Just in the last 2 years, that's actually already gone up to 5% of the of total internet access. So our goal at Mimosa, if we do our jobs right and we really build technology that is of fiber speed and wireline quality, is to grow that from where it's at today, about 5% of the industry, to over 30% of broadband access, by deploying something that's incredibly cost-effective and very valuable to consumers at a much, much more consumer-friendly price, and also reliability for the enterprise markets. So that was kind of how we started. So we've seen this trend go extremely well. I'm going to talk a little bit more about where the other technologies are at and how we evolved with them. Little bit on Mimosa ourselves. We've been in business for 3 years now. We just actually passed over the 100 employee count. We just actually opened our first office up in Istanbul, Turkey, which is a new R&D office there as well. So we're growing incredibly quickly. Almost 80 plus of these employees are all software and hardware engineers focusing on our backhaul and our access technology and our cloud technology. We're based here in Silicon Valley, and we are a venture-funded company with very well-known venture backing. So the focus that I want to put on today is really looking at the growth of where we're going over the next few years from a traffic perspective. If you look at what's happening in just trends, generally speaking, the cellular market, as you probably may know, represents only about 4% of total internet access. That means that almost all of the other traffic in the world is going onto Wi-Fi and wireline, offloading, home networking, and fixed access technology. And the growth is expected, based on the projections over the next few years, to really be in developing markets, as well as continuing to deal with cellular technology that can't handle the load. So what we're seeing is our opportunity as a company and our focus is really on WISP opportunities to grow them and continue to grow the rural areas, move into higher density markets with much better technology that can handle interference and be able to get capacities up, to be able to go into urban environments, and potentially enterprise environments as well in that particular case. And this is really where our focus is, where literally over 90% of the traffic growth is going to be fixed technology and Wi-Fi. And that's why we think we're in a very good position with some of our high-performance wireless access point technology in particular to really lead the way in this effort. Looking back to when we started the company, this chart just basically quickly shows what's been happening in the wireline industry. You'll notice that as we kind of predicted when we started the company, DSL has actually gone into full decline. And this is really great news for the wireless ISPs out there. As you look at this as well, you see how well fiber seems to be doing. But if you look a little deeper at the numbers, you realize that at costs of nearly $1,200 per subscriber, fiber right now is only really replacing DSL lines that are being pulled out in high-density markets, but it's not being used as fiber to the home technology in most markets where there's less infrastructure, in developing countries and in suburban density areas. So the opportunities are really very interesting for fixed wireless technology because they can really solve these higher speed opportunities in higher density suburban markets and developing markets that are very, very high density as well. And that's really where our focus at Mimosa turns to really grow the WISP industry into something new where it hasn't really gone after before, and solving Wi-Fi problems that people have not been able to manage as the growth of smart devices, tablets, iPhones, Androids devices grows. So one trend that I think is really interesting to look at that it really influenced our belief here. If you look back, 10 years ago, 15 years ago, the trend of the traffic, typically backhaul networks and DSL networks, et cetera, they were typically backed up by, T3s or DS3 technology. And really, the way that products were designed, especially in the microwave world and the wireless world, were to support this trend. Networks were designed for voice traffic, and they were symmetric networks. So your transmit and your receive bandwidth were roughly equal with each other. And that led to products being built, especially with FDD microwave technology and backhaul technology, to be only designed to basically be symmetric kinds of speeds. Now, if we fast forward to modern day, this graph I'm about to show you is actually a graph from one of our friends' WISP networks, and this is a graph of a day and what happens in their network. And at peak hours with Netflix traffic and other types of traffic like that and video, they're running nearly 95% in the downstream direction. This is just a ground shifting moment that realizes that we can't necessarily think about networks in the way that we used to. We need to be able to be flexible about how we deliver bandwidth upstream and downstream and how we plan for that into the future. And this is something that we very much focus on here at Mimosa, and largely why we believe our TDMA technology is very superior, because we can plan our techniques in the radios to be able to adjust to downstream versus upstream traffic very dynamically. And this is something I think that a lot of the ISPs that have deployed our technology have realized it's a big advantage and wastes less spectrum rather than having, for example, FDD radios, which may be wasting channels in the upstream direction, underutilized, and putting in more noise and interference into the spectrum. And this is a trend that I think we really see growing in a lot of ways. So, at Mimosa, just to give you an overview of all the things that we're really looking at, of course, we're focused on delivering fiber speeds. Why is that? Well, especially with the advent of Google Fiber and a number of different fiber to the home providers, everybody in the world believes that they deserve to get fiber speeds. The reality is that you don't need fiber to get fiber speeds, but also that socioeconomically you can't afford to deliver fiber in most parts of the world to every user. And this, we believe that Wi-Fi technology can lead the way. With all the advancements and investments in that market happening, we can take advantage of that. So today, while we've shipped our first backhaul units and we have links running at extremely long distances, our goal over the next couple of years is to be able to have backhaul technology that can start to match the speed of fiber. So our technology today is at about 1.5 gigabits of maximum throughput. We'll talk more about how you get there and what that does later on. But going into next year, starting to offer new technology that can provide far, far superior, higher bandwidths than that on the backhaul technology. Now, on the right side of this equation, on the access side of the business, we believe there's three markets that we have to address. And this really goes based on distance away from access points and that types of markets that we're looking at. In the urban environments and in suburban neighborhoods, we really have to, within 100 meters, be able to handle smart devices, Android devices, Apple devices, etc., that are walking up and down the street at medium, slow speed. Then, in the same environments, we also want to be able to provide urban-style broadband within a kilometer or so, and be able to make that experience, hopefully, a self-installable experience to help reduce the cost of the overall technology. So we're inventing technologies, especially for developing markets where there may not be infrastructure in apartment buildings or wiring, to be able to make self-installable a reality in a short distance in these urban non-line-of-sight environments. And lastly, where the traditional WISP market has been is in the suburban and rural areas where you're typically line-of-sight environment and you're putting up an outdoor antenna aimed at from the house towards an access point. And we obviously have to really address all of these markets to really achieve our goals in the long term. And we see a lot of interest from each of these market segments, from new ISPs who are attacking urban centers for the first time, high-density suburban markets where people have never been able to use wireless to successfully compete with DSL and cable, but they now can when we launch our gear. And in the rural environments where people are really just looking for better spectrum efficiency and spectrum reuse and better technology to be able to upgrade speeds, especially to meet the new broadband requirements that the FCC in the United States has come out with. We now have to achieve 25 megabits minimum to be able to claim we're doing broadband. And that's technology that we think that we can solve here. So this is the overall scope of what Mimosa's been working on. I'm going to walk through a little bit of what's been happening in the chip industry, because this is very relevant to our futures as in the industry and how we grow and keep costs very reasonable for these deployments. If you look at the chip technology, most gear that is in fixed wireless today, as well as most access points that you see both in the indoor home networking and enterprise business, it's been commercial 2x2 chip silicon. And that typically has been coming from manufacturers that have been focused on home networks and smart devices. Again, iPhones, tablets, low-cost stuff. But really, the challenge is that you're trying to scale up and build a cellular base station quality access point technology, and you really can't do that with the low-grade, up until now available silicon. And your choices are really to either go off and build something in an FPGA or build your own chip. The challenge with that is that you suddenly go into a system where you're no longer interoperable with Wi-Fi devices, it's not as scalable from a powering perspective, and the costs go very, very high up. So the choices, and I think why we've seen some stagnation with a lot of outdoor wireless equipment up until now has been because of this. Your choices were very limited, and the ability to move forward was very difficult. So what we looked at Mimosa was the way that the rest of the industry is behaving. There needs to be a separation between the technology in the client side, which needs to be very cheap, and the base station technology, which needs to be very high performance. So I draw a parallel to the cellular market, where if you look at vendors in the LTE band, where you have smartphones that have one stream of MIMO or two streams of MIMO, and you're dealing with vendors that are very, very different, on the handset as you are on the base station. So if you look at where the capacity needs are, you have people building their own completely separate technology than the guys that are building handsets. Now, let's draw parallels to the Wi-Fi spectrum. This is very, very different, actually, up until now, where even the access point and the client technology were brought to you by the same companies. But now, as we look at modern evolution to handle capacity and interference, we need a next generation of technology that will push us past the current limitations, get better capacity and better quality in the wireless network. And this is where we believe the big opportunity to step up and deliver more and better quality MIMO technology and multi-user MIMO technology, which we're going to talk more about in just a minute. And this is something that is absolutely unique to the chip partner that we've worked with and continue to do joint development with, Quantenna Communications. Quantenna has been an incredibly good partner for us. They have a very, very strong base of selling their technology to the Tier 1 telcos for distributing high-quality media distribution through home networks. So their customers typically have been the very well-known operators that you would know in Tier 1 markets for DSL, cable, and satellite for distributing media. Now, they've worked very closely with us, and we were able to really talk with them about the real issues with outdoor wireless and help develop a roadmap and jointly develop new chip technology that was going to make the wireless fixed industry outdoors scale in capacity. This isn't an easy endeavor. So one of the things that they're working on for us is increasing the capacity of the chip. We've just actually finished off the first early stage release of 8x8 MIMO technology. So today, we're going to walk through this in just a moment. We're dealing with 2x2 technology and 4x4 technology. Quantenna is going to be the only vendor in the industry pushing the edge forward to getting higher and higher capacity out of the chip technology. And that's what we need to wrap our technology around and then do a ton of engineering to make this work out in the field, be able to deal with spectrum management, co-location, synchronization technologies, and get the capacities that we need in the field. So this is something that we have worked with an exclusive relationship on with them, and you will see as a unique capability from Mimosa in our products. So I'm going to switch the conversation over to the technology a bit now and talk about this MIMO technology, or what we call massive MIMO technology. Massive MIMO is what we believe is the future of wireless that will scale up the capacity and also work in higher interference environments. So what does this mean? I should be expecting that clients should get better throughput per client. I should be able to get more clients per access point. I should be able to deploy fewer access points and reduce the amount of noise in the environment. The more MIMO streams that I continue to add in mean that I'm able to get more multipath in Wi-Fi and non-line-of-sight urban environments. And overall, I'm going to get more throughput out of these out-of-access point technology and backhaul technology. So this, in essence, helps us multiply spectrum. So how does this work? So looking at MIMO technology, today what is deployed is the 2x2 technology typically in the field. And most of the stuff that you see out in fixed wireless is sub 150 megabit 802.11n technology. Obviously, people are starting to move towards 802.11ac, but that's really kind of where the industry has stopped from a fixed wireless perspective. Mimosa introduced our first backhaul technology using a 4x4 radio. There's a lot of questions that people have about the way that we use the 4x4 radio. In fact, we actually split our chip into being able to do two separate stream sets of that 4x4. We're going to talk about that because I think it's a topic that does confuse a few people. But we're also introducing in our access points the first multi-user MIMO technology. What is multi-user MIMO? Well, not every client is ever going to get a gigabit of speed typically. So the best thing that we can do is try to share that speed of the access point across many users. And to do that, we have to create antenna environments and RF environments that are going to allow clients to be able to share the same spectrum using interesting and unique antenna technologies. So as I do this, I want to be able to aim my radiation patterns directly at clients and be able to split the bandwidth of an access point. So instead of a gigabit, I would have 2 times 500 megabits for 2 clients. So getting the baseband up while getting more clients onto the access point. So that was the first phase of the technology that we're working on our access points with. But when we move to the 8x8 technology that we've announced, that we've worked with Quantenna on, this will let us start to get up to 10 gigabit kinds of speeds with the multi-user MIMO technology and increase the capacity to 4 simultaneous users downstream at any one moment on the radio. That's going to be huge benefit in the Netflix direction, so to speak, or the video direction of end-user customers. And that's really, really critical for us to keep the speed of the access point and reuse of the spectrum up. So, massive MIMO, is it new technology? Not at all. This is stuff that's been used in 4G, LTE, and in 3G technology for years. Now, you've probably seen on cellular towers how they spatially distribute this stuff on different antennas, etc. Well, as you go up in spectrum, you actually don't need to actually have multiple separate different antennas. But the beautiful thing about this is we've already seen that there is performance and gain and over the future where we can go already has been shown that 16 by 16 MIMO is capable of being used to be able to get even more capacity out of the networks. So you can see that aligning with this technology and stuff that's been field proven in the LTE community is a really good thing, because if we can do this with Wi-Fi chip technology, we can gain access to that entire development community focusing on low-cost chip technology, but borrowing this great carrier-grade technology that's already been proven in the LTE market. And this is where we have such high confidence with this technology. So there's a lot of different ways that we use massive MIMO technology. So the first way that we've introduced, you'll notice that in line-of-sight networking, you only can get 2 polarizations out of your radios. So what does that mean? Well, every stream either needs to be polarization separated or spatially separated so that the other side of the radio is able to see it. Now, you can separate those streams by bouncing them off of buildings and off of different things in the environment, but when you're in line of sight, you can't do that. So the options that you can use are actually to build a lower cost radio by separating your streams and aggregating them into one product. So our first backhaul product does exactly this, where we take 2 streams and put them on one channel, and then we take 2 other streams of the 4-stream radio and put them on a completely separate channel. The beautiful thing that people that have deployed this so far like about this is it gives us inherent resiliency. So if I hit noise in one channel, I can continue to operate the radio on the other channel while I'm finding a better channel to work on. And that's entirely up to you as a customer to decide which channels you do and don't want to operate on, but this gives you flexibility that you've never had with backhaul radios to be able to adapt to the interference environment in a far more advanced fashion that's ever been done before. Now, the next major capability that is this multi-user MIMO technology, and this is where our access points really, really excel. And all of our antennas that we've built that you can see in these products here are all integrated antennas with the radio, so they're not connectorized radios, so to speak, like you may be familiar with other access points in the outdoor market. The reason for this is these are very advanced antennas with very unique designs around the directionalities of the antenna to create this great multipath and multi-user MIMO capability. What this is going to let us do is control the radio's directionality and the interference direction, so to speak. And we're going to show some examples of this because it's a very complex concept. We're going to try to make that really easy for you to consume and understand, because it leverages this new technology that's called beamforming. And beamforming uses intelligent antennas for us to adjust phasing and amplitude of the waves, and we're able to then create these unique antenna patterns only in the directions of the clients that we want. That's a super cool technology because that means that I can start to build client technology that's capable of aiming itself, so it can be easier and easier to install in the future. It also means that we're going to leverage these beams going in many different directions and bouncing off of things in urban environments to give us many different paths to get to the consumer, especially as we go add more and more MIMO capabilities and antennas to the radios. So this will only increase the quality of wireless performance in outdoor networks as we go on in time and get better capacity of the radios. The last key technique that we've harnessed in our MIMO technology is the ability to synchronize and reuse network both within the same co-located radios as well as across the entire network. So the things that we will debut in our access point line as we move forward will be able to host access points back to back and synchronize them for fixed wireless and share the same channel with 90 dB of isolation between the radios, which is incredibly high for the fixed wireless market. But also, as I synchronize the access points across the entire network, we can start to leverage very interesting cloud controlling techniques to be able to monitor every radio in real time, the spectrum, the utilization, capacity, and make sure that we're not interfering with ourselves across the entire network. And this is a key differentiator for Mimosa that we could pair together with intelligent radios and cloud management technologies to do the things that are very, very difficult to do in a dynamic fashion as an individual engineer would potentially manually try to manipulate. So you'll see incredibly advanced cloud techniques to increase capacity and interference management from Mimosa's technology overall. And these are the core tenets that we have behind all of our technologies to deploy. So I'm going to dive a little deeper on beamforming technology first. Beamforming, if you look at this antenna pattern, this is an antenna pattern of one of our antenna panels, the 90-degree panel of our access point. One of the really cool things about beamforming is I can create these really unique antenna patterns where I can control the directions of each of these different lobes of the antenna, and I'm focusing the energy and doing digital signal processing to get increased gain and performance. So I actually get 3 dB better performance simply by beamforming, as well as the ability to aim these different clients. So why do we want to aim these? So let's say I have a client in one location, and I have 500, 600 megabits of traffic that I could deliver to that subscriber. Well, great. I can aim the antenna intelligently and digitally, so I'm not using switching technology or anything like that. It's literally chip technology that is automating this experience, and I can start broadcasting traffic to that client. Now, meanwhile, I have another client that I know the location of in a fixed fashion, and I can take the other streams of the radio and do multi-user MIMO by aiming other antennas in a different pattern and null out the interference between the two. So all I need to do is cross the antenna patterns so that there's not overlap where those two clients are, and I can do this with thousands of combinations. Think of it as almost routing over the air to avoid the different antenna overlap. And now I can have two different clients that I can simultaneously transmit to. And this is a key technology capability that Mimosa will be introducing in our access point technology. So, talking a little bit more about fixed access, where we're really focusing on doing network-wide synchronization and getting better performance and spectrum efficiency. So, if you look at Wi-Fi, obviously Wi-Fi has huge value from a business perspective because of all the smartphones, laptops, tablets. But when you start to look at it for fixed technology, and I don't care if we're talking about the 5 gigahertz spectrum, the 3 gig spectrum, or 10 gigahertz spectrum, another area where Mimosa has been very active. Fundamentally, if you're going to be doing fixed wireless, it makes a lot more sense from an efficiency perspective to be using TDMA technology. It gives us control and efficiency of the utilization of the radio with none of the drawbacks of Wi-Fi as clients start to interfere with each other in outdoor networks. So this MAC-PHY efficiency is far, far higher with TDMA technology. And this is going to help us get our radios to be the highest capacity in kind of the first evolution. So this efficiency in fixed networks, we probably want to avoid using pure Wi-Fi for this reason. So TDMA is our focus. The other thing that TDMA lets us do is it lets us control time and it lets us synchronize the radios. So if I'm looking at two radios that are back-to-back, so to speak, I can have multiple clients on both sides of the radio, all using the same channel, and I'm reusing this spectrum. So previously, an old-school Wi-Fi radio would have just radiated the entire area and increased noise everywhere. We can now uniquely, discreetly control all of our streams at different clients, as well as use GPS synchronization across the radios and across the network to reduce interference. So this actually multiplies far beyond, 2x reuse on a tower. It allows us to reuse channels completely across the entire network as well. And that's going to be a very critical function as people are building kind of the networks of the future and trying to operate within a very, very confined amount of spectrum that they have available. So to do that, there's a lot of techniques that we've introduced that are quite new to this industry around managing, monitoring, and taking the next steps towards how do we get a very high-scale, high-performance, high-capacity network. And most of that comes in our cloud technology. So the first thing we introduced, I think a little less than a year ago, was our design tool. Right now we have about 1,900 ISPs all using our design tool in various levels of utilization to be able to plan out their backhaul links, be able to see line of sight, do fly-throughs, and estimate what kinds of performance they could get based on the amount of bandwidth they want to use, etc. This is probably the most advanced link planning tool that is out there. We also are set to put out in the market all of the access point planning tools to be able to see the view sheds where access points will be able to provide coverage and provide estimations of performance for that coming up pretty soon as well. The other area that I think our customers have really started to key into is the cloud monitoring piece. And today, we're already capturing live spectrum analysis. You don't need to turn down the radios or turn off the radios to do spectrum analysis. We are capturing out of every radio in the network live spectrum data and shipping it into our management system. So you, in your login to that system, and you own that data, are able to go back and look at a historical record of the spectrum analyzer. So literally, it's kind of like watching a DVR or TiVo for spectrum, so to speak, if you're to compare it to watching television. You can hit the rewind button now and have deep, deep analytics on all of the characteristics of the radio. Now, one of the cool things here is we've actually included this as a free capability with up to 24 hours right now of recorded data and spectrum analysis function. We will have longer options available, and we will extend, I think, a little further our free capabilities pretty soon. But this will be stuff that you'll be able to get indefinitely or longer periods as we introduce new service options here. But it gets you started and really gets you for free the ability to see how advanced this technology is. For guys that are less comfortable with the cloud or aren't cloud connected, we do have APIs available for you, both in REST, and next week we have a very rich SNMP MIB that will be available in our new software release coming out. So we'll have those MIB definitions out for all of you that are interested in that very, very soon, and you'll have complete flexibility to either use Mimosa's cloud or use your own data collection capabilities out of your existing monitoring tools. So give you a little bit of a preview as to what some of these capabilities look like. This is one of our test networks that we're able to monitor not just Mimosa devices right now, but internally we're also testing third-party SNMP management inside of our cloud, as well as SSH monitored third-party radios, etc. So you will see us having the ability to provide a cloud monitoring system for virtually any vendor routing or wireless equipment in one uniform package. So this is something that we have not formally shipped in the market yet, but you will see this coming soon, where you will be able to put a little proxy within your network to collect the data and then give you a uniform view of SNMP devices, SSH devices, and cloud devices. So there's no lock-in here. You have all capabilities to get whatever you want out of the radio, and you can start to look at Mimosa's cloud technology to monitor all different third-party types of devices as well, which I think we've seen a lot of interest by some ISPs that have just struggled to be able to get a really good modern monitoring capability and analytics capability. So some other things that we really like about the cloud, we really take pride in our support. We're going to talk a little bit about that. We have live very technical people that install radios every day here and ready to chat and being able to help optimize links. There's so many times that we've seen where if you help share your radio with us so that we can see some data, we can help optimize those links, and we've seen 300, 400, 500 megabit improvements by the time our support people come in, and you'd be shocked at the things that we have to do. Sometimes we reduce the power and we get better performance. And those are the kinds of things that we know how to optimize and help you get familiar with our technology, since it is new gear. The other thing about using the cloud is that it does qualify you to get a variety of different community awards, where every month we're giving out different awards for best links, most complicated installations, and things that we think the rest of the community would be interested in seeing, and giving you the ability to share your story if you want to do so. But we're constantly giving out new gear for different interesting things that people are doing. And also, we really prefer to work with people, especially in beta programs and things like that, that are cloud connected with us, so we can really help them out. So with that, I would be bereft if I didn't talk about a little bit more about the support. We've really done a ton of documentation online, and we literally update it by the moment for the field. We do have live people sitting there ready to take calls and provide extensive documentation. But really, we've actually, as a brand, I think, become known for our support. The people that we started off early with, fundamentally, we see people just buying our radios, not just because of the technology, but they come tell us that they bought these radios because they know we're going to be there to support them and help them get them installed. And this is something I think that's it's just absolutely a key difference with us compared to the other guys that are out there in this space. It's something that we are investing in because we need to as a new entrant into this space, and we will stand behind our technology. Last pieces I want to touch on are kind of the real-world deployments of what we've got out there right now. So there's three different backhaul products, two of which are shipping. I've put up the list prices per link that you should be able to see typically on the Streakwave site. The two products that are shipping are sold individually, so hopefully there's no confusion there, but this is a per link total cost. And the third product, the B5 Lite, is something that we announced just about 2 months ago. We're already got the first products out in the field with testers, and you should start seeing that hit the docks in the next 5 to 6 weeks with Streakwave, I believe. So this product is coming very, very soon. Now, the difference being here that the B5 products, which are our integrated B5 radio, and the B5C, our connectorized radio, are really designed for high-grade performance backhaul with synchronization, so that I can do relay links and co-location links, and our carrier-grade installation products. The B5 Lite is obviously a really low-cost but very high-performance system as well. So it can do roughly, these are IP speeds, not PHY rates, up to 750 megabits for $300 per link, and that's really the price beater globally right now in this backhaul space. And if you look at the different products, applications that you can see here, roughly speaking, we're going to see that used on very short links because it's a smaller integrated radio. And then for longer links, of course, people are using the connectorized product. So let's show you a few examples of how people are using product. The first example is Shelby Broadband in Kentucky, and they have a pretty significant co-location deployment of the Mimosa radios, and they're using a mixture of B5s typically, I think a couple of B5Cs, and of course for them, since they have a lot of water tower locations, etc., co-location is critical. So they were able to really upgrade their links significantly, up to 3 to 4x the speeds that they were having previously, and they really got use out of the synchronization and spectrum reuse capabilities of the technology. And this helped them actually aggregate their radios even closer to each other without any interference. They also got much, much better latency out of the system as they upgraded the gear towards the Mimosa gear. Next application is yet another co-location one from a company called Whisper in the United States out in Illinois. And they were migrating from, I think, a Cambium PTP 600, and they have bumped up over double the speed in a little bit less spectrum than they were using before. And really what they noticed was how easy this thing was to install, how light it is, and how low power it is. And that's the power of using chip technology as well as the really great antenna that we've built into the integrated V5 product. So these capabilities really change the game for them, and it leaves upside for them to open up a little bit wider spectrum as soon as they need more bandwidth. So the great thing about the radio is while they didn't need 1.5 gigabit, they can open up and go from 20 megahertz channels, or 2 by 20 as we like to call that, to 40 megahertz channels and use 240 megahertz channels to get double the performance. And this is a key capability for them. Now, a lot of people make comments out there about, you know, you're never going to find 80 megahertz of spectrum, or you're never going to find 160 megahertz of spectrum, which is what we need to achieve the 1.5 gigabit speeds. Well, we've seen that that's absolutely not true, even in some of the densest environments. It's really about getting SNR on short links. And we've seen, like in places like city of San Francisco, from building tops to building tops, people are doing quite short links, 1,000-foot, 2,000-foot links, and they're literally blowing through the noise in very high noise floor environments. And these guys are getting PHY rates of 1.7 gigabits in city environments with very high interference because you're blasting through that kind of noise floor. So we've seen this done very, very successfully. I caution you when people say there's just not spectrum to do this anywhere. Think of it application by application and make sure that you understand how and where you're going to use this, how long the links are going to be, and what signal level you'll have to be able to overcome the noise. And we've seen this done very successfully in enterprise environments and in urban ISP applications. And we've seen some extremely short links. We had a link out at the Super Bowl providing bandwidth to a party just across the street. They couldn't get cabling across the street to provide Wi-Fi access into this Bud Light party, for example, here that you see. So this was a quick event capability where they could put up the links overnight and get hundreds of megabits across the street and start providing Wi-Fi to the event. Great example of finding bandwidth where you could get it and quickly adapting to get bandwidth into the last mile. We've also got a number of very long links. One link we're showing here is actually flying over a fairly high noise environment over Silicon Valley, over the East Bay of San Francisco, up into the wine country. This was a 60-mile link put up on a larger dish, and we turned this up to 2 by 80, and this was going to a mountaintop on the other side. So it was typically going over the noise of the lower valley floor, and we were able to tune that radio up to over 600 megabits in that case. Now, a lot of people may not want to use those throughputs. That's obviously up to the ISP to do that, but you can absolutely see the flexibility you can get out of the connectorized radios in long distance. Other applications we have going over long distance over water. We have, for example, a 30-mile link from the city of San Francisco out to Farallon Islands, which are a protected marine reserve, and they're now getting, we've actually tuned this link up to over 300 megabits now, and we have a redundant dual situation out there because it's hard to get out to that island. So you can see that being used in a number of cases. So a lot of these links out there. One of my favorite ones is a ferry application where the ferry is actually a moving target, and they are putting radios on both sides of the shore, and literally we are recalculating the distance on a moment-by-moment basis with the GPS location, and suddenly you are capable of delivering speed, high speed out to moving devices out there. So this was something that we think that for the right applications in nautical markets, we see a couple of different applications already out in the field doing this. Okay, so that ends the formal presentation part here. I know Richard has a number of questions. Up on the screen here, I'm going to leave the how to get in touch with us for questions, and in general, if you have technical support, how to reach us. And also, if you want to follow our news as well as my Twitter feed, our Twitter accounts are up here. So with that, I'm going to hand back over to Richard and start taking questions.
Thank you so much, Jamie. That's a wonderful presentation, and we do have a lot of questions. Let me go through a couple of things first. First, a lot of you saw, and I got about 12 comments about the low battery. I'm sure they're plugging in their computer as we go. So we'll go from there.
Taken care of.
So let's start back at the beginning a little. We have a lot of questions about a lot of things. You talked about comparing with fiber and wired, and one of the questions that comes up regularly is the reliability. How realistically reliable is wireless to those other options at this point?
So I think what we've seen with the right planning, and especially as we are doing spectrum reuse, you can absolutely start to get in the nature of 4 to 5 nines of reliability, and that's our goal here was to get to a 5 nines reliability broadband service across the entire network, not just in an individual link. So what we're already seeing with the backhaul technology is as an early preview. It's the same technology that we're using in the point-to-multipoint, of course. So we're of the belief that we absolutely are seeing that reliability, largely because we're doing more intelligent spectrum analytics and picking the right channels for the right clients at the right time. And some of that's some of the newer technology we're doing in the point-to-multipoint. One of the big things that we see that is necessary is to be able to operate on potentially multiple different channels per access point for different clients that have different noise conditions. So you'll actually see when we introduce the full capabilities of our point-to-multipoint technology that channel shifting at incredibly high speeds to provide better noise environments for different clients on the same access point is a capability that will become a reality. So this ability to take into account the feedback of all the clients in the network, as well as just properly engineering this stuff, absolutely will get us there. So we're of very high confidence that the technology evolutions have moved us, and the automation capabilities we're building in will get us there as well.
So we had 57 different countries respond to this webinar, which is quite amazing. So talk a little bit about the frequency that you use and whether any licensing is required in order to use this equipment. I believe none of your equipment is licensed spectrum, but please tell me about that.
Not yet. So I'll give you a little bit of some previews there. So right now, all of our gear initially is focused on the 5 gigahertz spectrum. We have built the products to scale depending on the model and the antenna technology around it, from 4.9 gigahertz up to 6.2 gigahertz. Now, in the United States, since Streakwave obviously being a U.S. partner of ours, we are certified from 4.9 public safety band all the way up to 5.85, and we've passed all the stringent DFS and out-of-bands emissions requirements to operate in all of those bands. So we're a unique radio in that regard, and also for people doing public safety applications in the 4.9 gig band, we're probably the most revolutionary radio in that band in a long time. On an international basis, obviously things are quite a bit different, and power levels vary, as do regulations. So I think most people know their own country's regulations. We are typically following those, of course, in enforcing those using our GPS technology to make sure that we're following the local rules. So it does give us a broad global presence by using 5 gigahertz, but over time we obviously want to adapt and go into some different licensed spectrum where it makes sense. So I certainly would encourage all of you from different countries, we are not always global experts day one, but please do contact us on our inquiry to ask us questions about bands that would be interesting to you beyond the 5 gigahertz. We obviously see a lot of interest in the 3 gigahertz spectrum from people. And of course, Mimosa has been very active in talking through 10 gigahertz technology. So you can kind of imagine that we're getting pretty aggressive about going after backhaul technology in upper spectrum as well, both lightly licensed and unlicensed technology as well.
So let's talk a little bit about roadmap, since you guys have a lot of forward-looking things going on. You mentioned APs and CPEs and multipoint. When might we expect these to be coming into the marketplace?
Sure. So when we announced it last year, we had said it would be late summer, early fall. We're tracking to that pretty well. I think you can expect that products are going to be coming out roughly in the September to October timeframe for real general availability. And that's the early guys that are going to be ordering in the early process. So I certainly encourage getting engaged with the Streakwave guys to show your interest, because we do have a ton of people very interested in this new technology. So kind of getting on the early adopter side of programs that will I think soon be talking more to you through Streakwave about. I highly recommend that. We will be doing all of our, of course, our beta testing. We're already doing some of our own testing, of course, but the testing will begin at a number of customer sites in the early parts of the summer. So we'll start to release information about how things are going as we get closer into that. And we're a very transparent company. We will tell you everything about what's coming and when and how things are going as we know it. So I strongly encourage you to just ask us questions on inquiry. We're typically putting up on our blog and on our support site what's coming next in the next firmware release, not just the one that just got released, but what's coming out next. So there's always cool things that we're telling you what's coming so you can plan your network better.
Great. So I would like to turn to some of the performance issues at this point because we got a number of questions. You showed a picture of a 60-mile link. What kind of performance can I expect at that distance? And obviously, the laws of physics say some drop-off takes place in that distance, but what's the realistic distance for an average link, and what's the throughput for that? And then how are you dealing with that on a noise basis?
Well, yeah, so noise is very interesting because obviously it's geographic and everybody typically knows their noise floor to some degree and what they're dealing with. However, one of the unique things that we do from a noise management perspective is the radios are very intelligent on the backhaul side, and they talk to each other. Even in highest noise, the master side or the access point side is constantly talking to the client side and making sure that its spectrum and its local side, being very, very far away, is not undergoing conditions that are very different than the main side. So instead of just blindly setting up a few channels and hoping that the client side is just going to work, which we've seen a lot of radios do, and when they lose a link, you may have to drive out there to solve that problem, our radios actually communicate and see that noise is coming up on the remote side, and they share spectrum analysis, and the access point can be ready to move to additional backup channels that you've pre-selected and make an automatic move when you hit noise environments. So that's one thing. On your distance question, I strongly encourage people to use our distance estimator, but make sure that you're putting your noise floor into that calculator on our website. That way you can go in and put in the antenna size that you want, understand the power levels that you know that you can use in your country, and we have very, very good information about what the FCC rules and laws are on that calculator for the American side customers. And internationally, you should know your power levels for your 5 gigahertz band, and you'll be able to go in and get an estimate there. Now, to be frank, the best thing to do is look at customer data. Our cloud data that we collect anonymously to be able to see how people are using the product, I'd say on average, people are using the product in 5 to 6 miles is typically the strong average because that's where other products like in the 24 gigahertz spectrum don't operate. So I think when you're doing really short links, a lot of people like using various different technologies on 24 gig if it's like 2 kilometers or less. But if you go beyond that, there's not really a good answer other than 5 gigahertz or licensed technology. So we see our stuff typically being used between 5 to 15 miles is really the sweet spot. And then you really need to be engineering your decisions above that and know what you're doing to do long-distance links and managing interference around that for large antenna deployments on the B5C and the connectorized radios. So yes, it absolutely can be done at long distances, but you got to know your power levels.
You set me up, Jamie, because I needed to ask this question, and it was a perfect setup for that. How do I plan for that? I know you've got the backside for that. Tell me a little bit about the management side of things. How do I plan my links with your equipment?
Absolutely. So the first thing I would strongly suggest is if you go to our website at mimosa.co, you'll notice there's a link there to sign up for a free account, and that will give you very, very detailed, specific link planning. So you're able to type in an address or click and drag. And I'm sure many of you have seen basic design systems before, but I assure you this is entirely different because it actually will let you plan any type of radio in any spectrum, and it also is aware of your local weather impacts to the particular spectrum. So you could go in and put a 24 gigahertz radio, and we will tell you the average rainfall in your area and how you should plan your links based on the reliability that you should see in under high rain. So if you're in the monsoon season in India, you don't want to go more than a kilometer with 24 gigahertz technology, and that tool will tell you that. But more importantly, with Mimosa radios, they're quite a bit more advanced and different than stuff that's been deployed out there, and it knows the idiosyncrasies of working on multiple channels and the power levels that we're allowed to use, and it will help you plan out those links right there. So our design tool, I think, is super helpful in that. I know there's a lot of link estimators out there, but it doesn't always take into account the manufacturer-specific things that we do in the Mimosa radios. So we see a lot of people that have designed 20, 30, 40 links into their systems. I think some of our biggest customers we've seen have close to 40 units out there of backhaul units. Generally what we've seen is we sell a link, and then next thing we know, that customer buys 8 to 10 more. Largely because they saw the co-location capabilities and they saw the speed that they could get and the ability to work in interference.
So we just have a few more minutes left here in this session, and I want to go through one or two more questions. If your question wasn't answered directly, we will do our best to get back to you offline. There were an awful lot of questions, a lot of interest in this. A couple of little housekeeping things I want to do right here. The most commonly asked question that I get on all webinars when we do them is, boy, there was a lot of information there. I really want to see that again, or I want to show that information to my engineer. How do I do it? Within about a day, we'll have this presentation up on the landing page. We call it the micrositer landing page on streakwave.com and also on Streakwave's YouTube channel. So if you're interested in watching this or listening to it at your own pace, you can do that and you can pass it along. Just come to streakwave.com, look up Mimosa, and it will be under the tab for webinars or videos. You can also go to our YouTube channel. For those of you who are interested or have questions about this stuff, you can always call Streakwave at 888-604-5234 or come to our website. Let's go back to the questions. I want to talk a little bit about, you talked about the planning and the management. You talked about its efficiency and talked about the throughput. But let's say I'm putting this out in the field. How easy is it to deploy?
So yeah, I don't know if you saw some of the the customer quotes that we had in some of the use cases. I think that that's been the biggest piece of commentary that we've had, is that A, it's easy to install, B, I can put radios right next to each other, synchronize them, and not have to worry about interference. And C, once they're deployed and we start to monitor spectrum and see issues that come up, you have an incredible degree of control and automation about how do you operate when you may hit interference or new noise pops up as a new ISP or somebody else puts something up new in the neighborhood. And that's where the Mimosa products really shine, because they give you that degree of control and a degree of simplified automation. I strongly suggest not to just throw these things up and just let them rip. I think a lot of people, we've seen comments about that around this technology has a lot of automation in it. So you need to be, a respectful wireless citizen. Do your spectrum analysis. Pick the best channels for you, and allow the automation to do its job once you've selected a couple of good channels to operate with, and it will do a fantastic job of operating and continuing operation in noisy conditions. And that's something that I think is unique, because you'll be able to take stuff in the mid-band of 5 gig as well as the lower or upper band and pair those channels together. Now, think about that. I no longer have to look for a 40 megahertz channel. I can look for two 20 megahertz channels split in different parts of the spectrum. You've never been able to do that before with such ease and such reliability to adapt to the traffic. One other thing I would say here, Richard, is that the flexibility to adjust the bandwidth balance is also a key differentiator for us. So not just do you have a 50-50 mode where it's upstream, downstream, but you can adjust to 75% to 25% in the downstream, upstream, and synchronize that. And if you're not trying to synchronize, we have auto modes where the auto mode detects your bandwidth trends and automatically adjusts to the necessary bandwidth you have at that moment. And that's something completely unique in this space right now. that we're able to, if we see things like 90% traffic in the downstream direction, like I was showing you on that graph earlier, this product excels at dealing with those kinds of situations where it'll adjust the spectrum because it's TDMA technology, where FDD would be not so good at solving that problem and would leave a channel 90% underutilized. So I think, from a wireless perspective, it does a very good job in getting the most out of the spectrum it can.
I wish we had another hour. We've got that many questions, but we don't, and we always promise our audience that we'll end on time so that they can plan their day. We will get back to you. If you have additional questions, please feel free to give us a call. I want to thank Jaime Fink of Mimosa for doing this presentation today. If there is additional information that you need about these products, the B5, B5C, the B5 Lite, and or the upcoming products, always feel free to connect with us here at Streakwave or go over to Mimosa and connect with them. They are about support and they are about teaching about their products, so we're very happy to have those questions. Again, thank you, Jaime, so much for this wonderful presentation, and we look forward to the next one.
Thank you, Richard. Thank you, everybody.
Have a wonderful day, everybody. Join us for the next Streakwave webinar.